Amanda Potter, and this is my presentation on using technology in the classroom. According to the 2000 report, Rising Above a Gathering Storm, there is deep concern that the scientific and technological building blocks critical to our economic leadership are eroding at a time when many other nations are gathering strength. To combat this gathering storm, the report put forth 4 recommendations with top priority recommendations centering on the field of education, specifically building a strong math and science teacher workforce to support and educate the future science minds of America. According to the Organization of Economic Development, or the OECD, the Program for International Student Assessment, or PISA's 2006 report, in terms of student performance in science, the U.S. performs below OECD's average with a score of 489, due in large part to 24.4% of students performing at below proficiency levels. To compare, Finland, who is ranked number 1, had a score of 563. 38 data points equates to 1 school year, so the U.S. 15-year-old student is almost 2 years behind the Finnish 15-year-old student in terms of science performance. The Rising Above a Gathering Storm report assumes that there is a level of student interest in science education that exists or can be built upon using an increased science, math, and educator workforce. Certainly, innovative teachers, especially at the primary level, can begin to foster excitement and desire to learn about science. But right now, in 2012, how do current science educators deal with an apparent apathy when it comes to learning science? According to Christodow, in the 2011 study, Interest, Attitudes, and Images Related to Science, in regards to the relevance of science, students view scientific knowledge as an important component of their education, acknowledging its value for explaining everyday experience. However, they primarily stress the instrumental value of science, such as pursuing a career, rather than its intrinsic interest. In the science fields available in secondary education, such as biology, physics, and chemistry, students are interested in topics related to human health, diet and fitness, diseases and cures, as well as plants and animals. Students have shown that they are interested in biology-related subject matter more so than physics or chemistry. So the question becomes, if students appear to be engaged in learning science, yet this interest has not translated well into performance, what can we do as educators to parlay interest into accomplishment? It helps if we take a brief look at today's student and how technology impacts their daily lives. In the 2012 Pew Internet study, it was found that 77% of teens have a cell phone, up from 75% in 2009 and 45% in 2004. Of teens aged 12 to 17, 23% have smartphones and 54% have regular cell phones or are unsure of what phone they have. Not surprising given the data plan cost of smartphones, ownership of such phones increases as the student's age does. From 2009 to 2012, the volume of texting among teens has increased from 50 texts a day to 60 texts a day for the median teen user. Much of this increase occurred among older teens, 14 to 17, who went from a median of 60 texts a day to a median of 100 texts a day just 3 years later. 37% of teens who use internet engage in video chatting such as Skype or iChat. 27% of teens record and upload videos to sites such as YouTube, and 13% stream live video feeds for other people to watch. Given how tech-savvy our student population is currently and the state of distress our science education performance is on an international level, I wanted to look at how to tie together technology in the biology classroom in order to advance student achievement. The question is, will using web-based resources for online labs and activities have a positive effect on student learning in a biology class? The purpose of this study is to create a basis for understanding how utilizing technology in the classroom, such as appropriate and engaging websites and online learning activities, can increase the student's understanding of science concepts. Utilization is a way to bridge the gap between interest and performance in science classrooms by assisting educators with rooting science concepts in their students, and is also a way modern-day students can relate better to the sometimes boring and uninteresting subject matter found in biology. With the youth population that has grown up with instant access media, computers, and the internet, it is no surprise they bring with them different expectations of how they will receive and provide information in the classroom compared to generations before them. Having fun and innovative ways to capture students' attention means that students, for example, can utilize virtual learning experiences to be able to visualize and interact with dynamic processes in the body to learn instead of relying only on textbooks, lecture notes, or plastic models found in the typical lab. The point of using technology in the science classroom, no matter what the specific technology is capable of doing, is to engage and empower students as scientists by providing them with the opportunity to learn valuable technological skills, to apply knowledge to solve science problems using real data, and to become involved in real life. The participants of this study are evening high school students enrolled in a first semester biology course. The class roster has 19 enrolled students, though in every class there were generally only 15 to 16 students at a time. They range in ages from 16 to 19, with the majority of the students in their junior or senior year. The students were of varied races, ethnicities, and sex, with the class being nearly evenly divided between white students and students that are either African American or Hispanic. Likewise, the class is almost evenly divided between males and females. The environment for this study is a unique one, as I'm not their tutor, but rather the class teacher assistant. I'm in class with them every day, Monday and Wednesday, assisting the teacher on record, Mrs. Q, to maintain class order, and also to step in to teach class when Mrs. Q is unavailable. Instead of having an individual or a small group to utilize for the study, I was fortunate to have an entire class to do my planned web-based activities to give a little more depth to the data results. Also unique is the student body itself. They are students who receive their high school diploma, not a GED, and are enrolled in the evening program for a variety of reasons, most of which are not all positive ones. The daily classroom environment, to be put mildly, is not one of eagerness and enthusiasm for learning in general, much less about learning science. The procedures I used for the study in broad terms was to give the pretest, review the activity and associated worksheet before the students began to work, give the post-test after the activity was completed, and then hand out the student opinion survey. The pre and post-test given to each student in the class prior to and after the lab activity were 5 questions pulled either from the lecture or the lab work itself that were the same in the pretest as the post-test. I chose to do pre and post-tests to determine if learning had occurred based on 2 studies I have found that dealt specifically with web-based activities in the science classroom, Kay's 2011 study and Slucas's and Park's 2006 study, both of which can be found in the reference section at the end of this presentation. 4 online labs and activities were given on the subject the students were currently working on in class. The topics were macromolecules, nutrition, cell membranes, and cell organelles. The activities ranged from online laboratories to discover what substances had sugars, to researching questions online, to nutrition, and to completing a virtual cell membrane. The student opinion survey was also given to all students who completed the post-test if they did the activity. The surveys for each activity had the same 4 questions. 2 questions asked students to circle on a 1 to 5 Likert scale with agree at 1, neutral at 3, and disagree at 5 on whether the lab activity was difficult or confusing and if they felt they understood the material better after completing the lab. 2 questions were open-ended, asking them to indicate what they liked about the lab and what they would change about the lab. I analyzed the pre- and post-test data by averaging their scores and comparing the pre-test score to the post-test score to determine if they indicated any learning had occurred. I also averaged the lab scores, as well as averaged the student opinion survey data on the students' perceptions on difficulty and understanding. As the activities grew in number, there were certain trends noted. The first was that as students continued to participate in the activities, there was an increase in the amount of post-test questions they got correct compared to the pre-test. The notable exception is the nutrition activity, where the student post-test score is a likely reflection of the confusion that was caused by incorrect links and outdated worksheet questions. This to me says that the students became more comfortable with the idea that the activity provided them with the knowledge they needed to perform well on the post-test. The second trend I noticed was that by the time the students had finished the post-test on the 4th web-based activity, the phenomenon of performing better on the pre-test than the post-test had disappeared, a phenomenon I called score reversal. In the first activity on macromolecules, 5 out of 14 students, or 35% of the students, displayed the score reversal. In the second activity on nutrition, 3 out of 7, or 42% of the students, had score reversal as well. The percentage had increased from the first to second activity, but the confusion from the activity itself likely had an effect on scores. Strictly speaking numbers, there was a decrease from 5 to 3 students in between the 2 activities. In the third activity on cell membranes, the percentage of students who showed score reversal had decreased to 13% of the students, or 1 out of 8 students. Finally, 0% of students had the score reversal in the cell organelle activity, the last one. Again, I believe this has to do with the comfort level being built where students are trusting that the information they need is in the activity, that these are not assessments intended to trick them. I would also like to believe that the students are beginning to trust themselves, that if they believe the answer is correct in the pre-test, they can either confirm it during the activity or trust that they were right for the post-test. The third and final trend I saw from the data was that there was a correlation between the post-test scores and the students' perception of difficulty and understanding of the activity. As the students performed better on the post-testing scoring, their perception that the activity was difficult decreased, or as shown, their disagreement score increased. Also, their perception that they understood the material better after completing the activity increased, or as shown, their disagreement score decreased. This correlation has a slight anomaly for the first activity in macromolecules. The anomaly could be attributed to the students settling into performing web-based activities in this particular class, which could explain why the scores for the macromolecule activity were stable for the pre- and post-test comparison, yet students exhibited a great degree of understanding and believed the activity to be easy to complete. The correlation holds true for the other three activities, however, in that students performed more poorly on the post-test in the nutrition activity, and the students acknowledged it was more difficult and they understood less about the material covered. In the final two activities, the students performed well on their pre- and post-test score comparison, and their perceptions of difficulty and understanding echo those results. Findings are these. First, that enough time must be given to allow students to acclimate to using technology in the classroom if they are not already used to doing so. This can be alleviated by using laptops or computers early on in the class and continuing to do so in a consistent manner. The students in this class had rarely used laptops up until the first activity, and I think that the novelty of working on a computer may have caused them to lose concentration regarding the purpose of the activity itself, and therefore did not use it to learn as they should have. Later in the semester, as they used the laptops more frequently, their post-test scores improved. Second, students also need time to adjust to a particular method of assessment if it is new to them. Doing pre-assessments was already part of their standard routine, but only for each new unit, not for each activity as I had them do. Also, receiving a post-assessment right after the activity, sometimes in the same day, was something new for them. By the time we got to the final activities, they were adjusted to the new routine, or rather, the routine for online activities, and that comfort level could have contributed to the increasing post-test scores. Finally, when students do web-based activities they feel are easy to use and also easy to understand the material presented, they perform better on post-test. Therefore, care must be taken to level the web-based activities for the students so the activities are not too difficult for them to understand, which includes the terms and vocabulary used in the activity itself, especially if there was not a lecture on the material covered prior to the activity. Also, ensuring that the activity is easy for them to follow, that it isn't confusing or incomplete is crucial. Students got frustrated with the nutrition activity, and rightly so, when they were unable to locate the information required on the worksheet. This likely caused them to shut down and prevented them from learning much on the material covered, as evidenced by the low post-test scores, not only in comparison to the pre-test scores, but also in comparison to the other activity scores. Overall, I believe using technology in the science class was effective in increasing student knowledge. Students enjoyed working on the laptops and working with web-based activities and showed that there was a certain degree of learning occurring. However, my results mirror those of other studies that looked at technology in the science classroom, in that the web-based activities are effective when they are done in conjunction with traditional learning, such as direct instruction with lectures with note-taking. Specifically, in a 2011 study, Martinez et al. Noted that statistically speaking, their results of a 3.4 percentage point gain in student knowledge using technology is not significant, but educationally it is. That even though the students can improve their content knowledge with web-based means, there is still the belief that technology should be used to complement and support the work done in the classroom to reinforce ideas and concepts learned. I believe that science teachers should make a concerted effort to engage students through technology, as well as through traditional classroom methods. The evidence of increased learning, no matter how statistically insignificant in an analysis, could potentially lead to a full letter grade change for some students. Anecdotally, in the study, in the classes that the students worked on the laptops, these classes were the ones when the students were most focused on their work and least likely to look bored or disinterested. In my own classroom, I will add web-based activities to my normal practice. The student engagement factor alone was enough to convince me that allowing students to use technology when they themselves are technology-driven individuals is the right way to go to make students more interested in what is being taught in biology. Having a small data sample of the positive effects of technology can have on assessment scores further reinforces my decision. There are several things I will do differently in moving forward, both as a basis for my action research project and as a classroom practice. I will either create web quests from scratch or do a better vetting process of the ones already created and posted online. I will also make adjustments to the student opinion survey. One thing I will change is the Likert scale statements. While I like the idea that it made students really think about their answers because the scale statements prompted them to ideally disagree with one statement and agree with the next one, it was confusing to analyze in a meaningful way. It could be done as I attempted to do, but there was quite some time spent on how to present the information to keep the audience from getting confused by what they were reading or seeing. I would also like to add more Likert scale statements and keep the 2 open-ended questions. I believe there is more information to gather from students on what they thought about the activities. Topics most likely to be included in the revision will be regarding the length of time it took to complete the activity, difficulty of the vocabulary used, and if having a lecture on the material prior to the activity was helpful. I will also modify the data I collect to answer my research question to explore possible additional correlations of data, namely root causes of score reversal and the correlation between the student perceived difficulty of an activity and their post-assessment score. In conclusion, using technology in the science classroom appeals to the modern-day student and correlates to positive post-assessment scores, which indicates increased student knowledge of science concepts. Thank you.